So in this video, we'll quickly see how to evaluate one or more models. We had a tree model built through repeated or recursive partitioning, and we can quickly evaluate using some of the well-known measures such as area under the curve, misclassification error, precision recall, accuracy, sensitivity, and so on. So there is a package called ROCR which has built-in methods. We had computed these by hand in the last video, but there is no need to do that. So let's quickly define a variable. So I'm creating a variable called predict matrix. This is just to hold the various classifications and labels. So labels are essentially the actual values of response variables, which is present and absent, and for this process case. So what I'm doing is I'm essentially I'm listing this and converting this into the numerical values, so that instead of present or absent, we get levels as 1 and 2, which in turn can be used to match with the ready-made output when we use a predict method and matrix as the type. So let's quickly do the fit model. So this fit model is the recursive partitioning model that we discovered last time. And then what we would do is we would use the predict method, the ready-made predict method, and we'll pass the type as matrix to get the levels as well as the predicted likelihoods. And so this will look something like this. What I have here, after I select the appropriate columns, is the likelihoods for, so there are two likelihoods, and this is essentially one likelihood is 1 minus the other likelihood, so they both sum to 1. And so if I know that let's say the column 1 is 0.42 and column 2 is 0.57, so I know that the level 2 is selected. That's the second value of the class variable. So if I say that the class variable, the first value is absent, then the second value will be present. And that's how I would compute. I'll take a function Pmax to get the maximum of the two. And so I know that my final predicted value is the max of the two probabilities, because having both columns is redundant. So we know that it's one probability is 1 minus the other probability. And then we take the ready-made prediction function from the ROCR, and then we pass the labels and the labels from the original response variable that we need to predict, and the computed probability which is learned from the fit model. So let's quickly look at how this DF matrix looks like. So you can see that it has both labels and likelihoods. So now we'll take so for instance here we had okay, so let me just quickly add this again just to ensure that we have both values. We have the labels, and then we would also have the likelihoods. And then we can see as to how it will look like. So once that's done, we can quickly use the ready-made functions, compute the thread values. And here it basically, so this is a built-in package, so it will compute all the necessary functions that are needed. And if I will use that, I will just call a performance function, and then I will pass the two variables. So if I have to plot sensitivity and specificity, for instance, I will just pass on the values as my prediction output, which is the output of the inbuilt prediction method, and then I will pass on the sensitivity and specificity as strings. and then I'll just do a simple plot, and this is how I get it. And similarly I can do a precision and recall. So instead of completing by hand, I can use the package inbuilt methods to achieve this in a much faster manner. So let's do this for precision and recall, and then we get the corresponding code.